Hello!
Hello and welcome to day 11 of our Advent Calendar.
Codemas.
Yeah.
And Phoebe has been preparing a highlights reel.
And it's going to be on my channel. There should be a card up in the corner. So.
And a link in the description.
Yep, and also in the playlist. So if you ever want to go and check out the funniest parts of days 1 to 4 so far, you can just check that out.
Let's get 11 open.
Another one of those diode boxes. And we've got
Oh, that's
more mail-to-mail. And what do you think that is?
I think that's a display.
Oh!
I think that is a display.
This is mine after this. You know, after this Codemas thing, this is mine.
Oh, I see.
The same jumper wires.
Day 11. OMG OLED. Nice.
OMG.
So OLED, the O in OLED is it's an organic LED display. Great for showing data. I think this is just a single color, but it uses I2C. So organic light emitting diode. You'll see this in TVs, you'll see this in phones. It's probably what this screen here is using. I2C integrated circuit. We did that one-wire communication with that temperature sensor.
Yeah.
And this one, it's a two-way communication system using two of these wires. So there'll be one for ground, one for voltage, and two of them for data.
Oh.
So it's a data bus. Oh,
okay.
wow. So today we are finally removing the LED and buzzer input components.
I'm doing this. I like destruction.
You like destruction? Okay, well, I'll disconnect it from my nice glued down, very nicely put together. There we go. You can start removing all of those bits. I'll give you those boxes. I've been using them to store stuff in.
They were nice boxes. Wait,
They
scroll
are.
down.
Yep, it is everything.
Bye-bye LEDs. Bye-bye resistors. I think if I put these resistors in, these will wire terribly for me.
Right, okay, so we have just the Pico.
So, and I need a button.
Okay, I shall get the buttons. Got to find out which boxes the buttons went into.
Flimsy a little bit like. That's the button we're using, I'm guessing. Okay, here we go. We need to add these.
1, 2, 3. I'll lay those out for you.
Put it up. It's really difficult trying to do this while looking through a camera.
Yes, everything is more difficult when done through a camera. Well, keeping things in shot.
Yeah,
keeping
that's
your hands
really
going.
difficult.
Yeah. While also having to kind of retain coherent speech while doing them too. Hurrah! Yeah, coherent speech is overrated.
I don't know what
You have nothing to say. That's fair. Another one. 3 pins in here. Pin out there.
Look at that! Oh my goodness!
There's only 3 more wires.
The yellow one isn't fully in.
11th pin. Having this numbered breadboard is helpful. A bit of a rat's nest. Okay.
That looks like what my mind is like when I'm trying to sleep.
A light sensor from box 6 in our example today. If I'd have been thinking about it...
You would have put it in boxes, but you didn't.
No, I just put them in whatever box. But it might well be in box 7. The other ones have all been mixed up, but that made sense. That was a good call. So we're going to use the mini breadboard for that. Okay, and obviously we're going to need 2 more jumper wires.
Or more. No jumper wires yet.
Long leg light sensor goes to the left.
Guessing I'm doing a lot of the code today.
Yep.
Sounds good. I like the code. It's all fiddly and tiny and but the concept is pretty simple.
One of the things I would be doing, to be honest, if I was doing this as a breadboard that I'd be keeping or maybe using for longer, is I would be trimming these to fit. All of these so it fits neatly. If you want to see neat breadboard wiring, I thoroughly recommend Ben Eater, channel where he makes rather amazing 6502 based computer boards, and he makes them all on breadboard.
Oh wow, that's nice.
Oh, we need 3. There we go. So we get a 3rd cable. So
I did suggest it.
there we go. Right. So that goes into ground. Middle one goes where pin 10 is, which is I think going to be the same GPIO 26. Positive there. Okay, there we go. Okay, now we need some code libraries.
Okay, I'll let you do this.
So our display is going to need a package that isn't included in MicroPython. Okay, so we're going to get to do something a bit more interesting. So this is an OLED driver, Command A, you're absolutely right. We'll go to Thonny. So we're going to save it as this thing here. There we go, it's connected to the Pico.
And we can save it down to the Pi.
Now we kind of did something like this with that tone library that we made.
We did.
So
we imported.
And when they say close, there is a class. In fact, there's multiple classes. Yep, there's an SPI and an I2C class. Not that we'll use the SPI class because we've connected it by I2C. Now they say to close it. To be honest, as long as you open a new file and work in a new file,
edit the original file, you'll be okay.
Tools and manage. Okay, tools.
Manage packages.
Manage packages. SSD 1306. This must be the kind of chip we've got on here. Search on PiPi.
PiPi.
D1306. Sure. Okay. Okay, I2C. So we're going to need to import I2C.
Accident prone. So what this will do is it'll import stuff, import from that thing that we just imported, and then it will import time, which is quite normal, including some sleep.
So, well, I2C, we're setting up an I2C bus using pin 0 and 1 that we plugged into with a nice fast frequency. So this is going to be really quick.
We'll clear the display by filling it with nothing, and then display the text "Hello World" and display.track.
And the display is set up with both the I2C port and also a width and a height.
Right, yeah. Day 11, Hello World.
Oh, it's this way up.
Hello World.
So
Activity 2, multiple lines of text. Let's go one step further, and there are some arguments 0, 0. I'm guessing those are coordinates.
That would be my guess too.
Our display, that's a useful piece of info. Our display is 128 by 32 pixels. Give this example a try and then play with the argument values. Okay, so it does the same things, but we can choose what goes in here.
Do you want to change something more exciting to line 1, 2, 3?
So we've got something to show you, and we'll save this as day 11 custom.py. And let's have a look at what we've given you. Oh, I didn't display it.
Oh, because you tried too many fancy characters. Okay. I don't know. It's got a smiley face and a pear tree, and that top one was supposed to be a shrug.
Yeah, it was supposed to be a shrugging face, but apparently it doesn't like that.
No.
I tried.
It's quite picky about what characters it wants to display, so kind of expected.
Okay, well, what's next? The endless counter.
Okay.
Endless counter on the using the display. Converting integers to strings, we get that, and here's the code. Let's have a look then. Okay, 3, 2, 1, boom.
That is counting pretty quickly, and it is matching
this graph. Now, what I want to do, I've been doing a little bit of Python work recently, so we get a more funky graph.
Okay.
Wait, mine is 3 to 3. Then we're going to get a funky graph here. Let's try this. See, it's random now. Yep. Randomness is more fun than not. 4. Activity 4, the naughty or nice game. Sounds very Christmassy. The code. So, nested if statements. This next piece of code is going to be a game, I'm guessing. This is what the button is for. Do you want to be our test subject?
I'll happily be a test subject, yep.
Day 11, naughty.py. Naughty or nice?
Okay, so I think it depends on how quickly you press this button, which you get. Nice! Yay! Okay, your turn. Naughty.
Oh, that's so mean.
Well, we know who's getting nice presents. Right, what's next?
I think that might be day over.
No, because they got us to add a light sensor.
Activity 5.
Show me the light.
Create a variable called light and copy the code over to Thonny. It displays the light level.
Oh, on the sensor. Okay, as a percentage as text. Okay, cool. Yep, let's give that a go.
Day 11, light level.
If I cover that over, 5.
40.
40. That really, I can bring this closer. There we go.
High.
Pretty cool.
Day
11 is complete. Well, I am wondering what the limits of this display class is. Does it just do text? Okay, I was thinking we could try and make it do a graph on the display.
Ooh, okay.
We took this library over here. Oh, subclassing frame buffer, lots of graphics primitives, PyBoard frame buff. So So we do fill 0, there's text, we can do a horizontal line. Let's pick up the hello world. Let's draw a little line under this. So if I do display.hline, x, y, width, height. x0, we'll do y20. I don't quite understand width and colour, got you. So if I do a width of 128, put a 1 for that colour then.
Hello world with a line under.
And all the wires are in front of the display. And the other thing we can do is polygons, we can do text, we can scroll. So what we could do is if we go back to our light sensor, do the clear the display once at the start. Light height equals light times 32 divided by 100, I think. If I was to say V-line, we have V-line up here, 0, 0, line height 1. And what I'll also do up here for the delay is we can do display.scroll, and there's a scroll vector here, which I think X step. Can I just say display.scroll? If I do 1, it's going to be going the wrong way, but that'll be fine. So it's going to go that way out, and it's going to be graphing from this way in here. Let's turn off the text. I'm going to run this.
Let's have a look.
Line height isn't defined. Light height and line height.
Displaying a tiny box.
Quite what I meant. What if I 31? I'll tell you what we'll do also. I'm going to print this light height so we can actually see this variable output. Let's try bringing the light in close.
Studio light. Oh, it's gone all the way.
Yeah, the graph isn't changing though. How does this thing work? Maybe I was right the first time and the line height was just short. Ah, there's our graph. The scrolling, because we've got some kind of graph shape here and then the rest appears to be just white. Maybe with the scroll we have to say what it fills with. Scroll, it doesn't really say what it's gonna, it may leave a footprint of the previous colors. So, and we do also a display.vline 0, 0, 32, 0. Draw that one side gets cleared, one side gets drawn on. Graphs turn out to be trickier than I thought. Ooh. Okay, it's kind of upside down, but it's graphing. Look, it's the same shape.
It works.
We have a graph.
It looks like a building.
I think we've got our graph. I think we've got the display to do something a bit fancier than just text.
Yeah, that's
cool.
done.
Hope you've enjoyed that, and I hope you've enjoyed our few experiments.
I'm going to leave you with the anticipation of what's in the big
D12
box.
is coming.
What's in the big box?
What's in the big box? Right, well, go make stuff and be awesome.
Don't forget about the highlights videos. And
Bye.
we'll catch you in the next one. Bye. Oh, I'm going to
okay.
push that in. Ow.
Spiky.